Hello everybody. I'd like to talk about inheritance. I know that a lot of you know about inheritance already, but I'm going to add some things that you probably don't know, and we're going to focus on some sort of edge cases and other things that you probably don't know. So I'm going to say before I start, things that you're supposed to know at the end of this are you should know what an is a relationship is, what a has a relationship is, what a parent class is, child class, superclass, subclass, what inheritance is all about, and I know you know that, but some details regarding that. What's the difference between method overriding and method overloading? You should know what extends means. You should know how the concept of casting applies to objects. You should know what downcasting is, and finally you should know what polymorphism refers to, and why it's cool and useful. Okay, let's get started. So if you haven't printed this handout out for yourself, you probably should, because I think it's more helpful to look at it on paper. So take a couple of minutes and look at the three classes that I have here. I've got a student class, I've got a Stanford student, which extends student, and I've got a grad student, which extends student as well. I want you to notice what are the fields that all of these have, what are the constructors that they all have, what are the methods they all have, and just kind of notice things that are different that you might not recognize or that you might have questions about. So take a couple of minutes and just kind of wrap your head around what's going on with all this code. Okay, I'm going to give a brief kind of talk down of it. So we've got student, we've got a bunch of private fields. So students have names, they have a grade, which is an ambiguous term. By grade, I guess I mean A, B, C, D, or pass or fail. And then they have an array list of integers, which represents their test scores. So the student class has two different constructors, a no parameter constructor and a constructor that takes a name as a parameter. So notice that all of my fields are getting set by the constructors. You might be unfamiliar with this syntax where I have the keyword this, and it's being used like it's a method, like this and then parentheses. This is how you run another constructor. So my no parameter constructor is actually running this other constructor, but the input is default student. That's the argument that it's giving to this parameter n. So if somebody tries to construct a student with no parameters, it's going to actually end up running this other one, and so the student is going to be named default student. All right, getName, getGrade, those are simple enough. setGrade, that's simple enough. So compute grade runs the get test average method down here, and if the test average is more than 65, we'll set grade to pass, otherwise to fail. Get test average, the only potentially new thing here is I'm going to try and use this for each loop style syntax more. You should definitely know how that works for the midterm. Briefly, how it works is you have a colon. What happens right before the colon is a variable declaration. So you want to declare a single variable whose data type is the same as the data type that is this list data type. So on the right side of the colon is going to be some type of list. It could be an array, it could be an array list, it could be other data types. So here, because test scores is an array list of integers, on the left-hand side of the colon, I am declaring a single integer variable. And the way the loop works is it automatically takes the first element from the list and assigns it to score and runs through the loop. Then it takes the next element from test scores and assigns it to score and runs through the loop. So in other words, this loop is going to loop once for each value inside this list. Okay, so that's student. Stanford student extends student. So what does this extends mean? Extends means that Stanford student is going to be a subclass of student, also called a child class of student. So if this is a subclass or a child class of student, then that means student is a superclass or parent class of Stanford student. So the subclass, so superclass, subclass, parent class, child class. That's the relationships. So I've gone ahead and notated that here, the subclass and the superclass. If I wanted to, I can make a class that extends a class that extends another class. So I could define a class called Stanford Undergrad, which extends Stanford Student. And in that case, we would say that this is a subclass of this one, and this is a superclass of that one. But this is a subclass of that one, and this is a superclass of that one. So the other thing that extends means is the class that's extending another class inherits all of the fields and methods from the parent class except the constructor, because it doesn't really make any sense to inherit the constructor. So for our specific example here, Stanford student, if you look up here, it looks like a Stanford student doesn't have a field for name or test scores or anything else, but it doesn't need to because it inherits them from the student class. So you might wonder, how does private figure into all of this? We'll talk more about that in a minute. For the moment, let me say that Stanford student inherits all the fields, including the private ones. Private only has to do with who can access the fields, not who has the fields, which is a subtle distinction that I'll say more about in just a second. In addition to fields, I said the child class inherits all of the other methods as well that aren't the constructors. So the child gets all of these methods. You might notice here I'm running super. What super does is super runs the constructor of the parent class. If your parent class has more than one constructor, super is going to look at what parameter list is given to decide which of the constructors matches that parameter list. So here I'm running super with just a string, so it's going to run the student constructor with a string as input. If I'd run super this way, then it would run the no parameter constructor of the parent. In addition to calling the parent constructor assigns values to all of the inherited fields. So Stanford student gets a name and test scores and grade. The constructor here isn't setting their values, and in fact the constructor here cannot set their values. If I tried to do this, if I tried to say name equals default, that would be an error, and that's what it means for name to be private. It means that nobody except an actual student object has access to this variable. Okay, so here's the confusing part. A Stanford student still has a name. They still get this name variable. It's just that the Stanford student object doesn't have direct access to the variable that they inherited. And that's one reason why you want getter and setter methods. If you have a setter method that's public, public means anyone can run it. So the Stanford student would be able, for example, up here to say set grade to NA. And that would work because the set grade method, well, the set grade method is protected. Protected means that only the class itself or any of the child classes can run it. So because this is a child class, we're able to run this method, and this method then sets the private field because it's defined inside student, so it has access to the student private fields. So long story short, when a child class inherits fields, it still inherits private fields. It just can't access them directly. It can't read them. It can't write them. So if you want to read or write them, you have to run public or protected methods in the parent class in order to do that. Then, in addition, the constructor also needs to initialize whatever fields the child class itself has, and so that's why we need to, separately from calling the parent constructor, we also need to give a value to the Stanford student field. Okay, so compute grade. Notice that compute grade also exists in the parent. There are two versions of compute grade, and they're different from each other. That situation is called method overriding. So the child class has overridden the parent method. It's important that the child method have the same name and the same parameter list as the parent. Otherwise, it's not really overriding it. You're just creating another method that's very similar to a parent method, but not the same. So the reason you might want to override a parent method is if you want the child to be able to perform whatever function that is, whatever behavior that supports, only they're going to do it in a different way. So you've still got the parent method, you're just doing it in a different way. Overriding is different than overloading. Method overloading is if you have two different methods in the same class that have the same name but different inputs. And method overloading is for a completely separate purpose than overriding. Okay, last class. So grad student also extends student. We're also running super, so a grad student has a grad ID, and we're running the parent constructor, and we're setting the grad ID. We've got a getter method for the ID. We're also overriding compute grade for the grad student. Only here, you'll notice I've run super.computeGrade. What super dot does is, super, of course, refers to the parent class. So super.computeGrade runs the full compute grade method of the parent. And then you can do additional things besides that if you want to. So this is sort of an alternative to overriding the method completely. It's like I'm overriding it, but maybe I actually want to do the same thing that the parent had done, only I want to do some extra things. That's a situation where rather than copying and pasting, rather than overriding it and having code that's the same as the parent followed by the code I want, instead I would just run the parent version and then afterwards do the things that I wanted to do. Okay, here's where it's going to start entering new material. So sometimes, well, I've seen this on the AP test, but like literally nowhere else. The AP test refers to this as an is-a relationship. And the reason why is because a Stanford student is a type of student. Even though I think that's maybe kind of a silly term, it captures a very important idea, which is that child classes are like elaborated versions of the parent classes. So a child class is something that has all of the variables and methods of the parent, plus some possible additional variables and methods. So more conceptually, a child class is a type of the parent class, but it's like a more specific, specialized type because they can do additional things. So this is important because of casting. So if you remember from before, casting means, casting is a way of treating something as if it's a particular data type. So here I've got a double and I'm saying treat it as if it's an integer. So let's pretend that I've made a new Stanford student object and I've stored it into a Stanford student variable called p. I can treat p as if it's a student, because a Stanford student is in fact a type of student. So you're able to cast the p variable to be treated as a student data type because what's inside p actually is a type of student. And then if I wanted to, I could save it into a student variable rather than a Stanford student variable. Actually, you could do that anyway without the casting. I could do this, again, because p is a subclass of student, and so p is a type of student. So p has all of the methods that a student has, so it's safe to save it inside a student variable. I think this is an extremely helpful way to think about the situation. So let's compare the two situations where we're trying to take a grad student object and save it into a student variable versus a student object and save it into a grad student variable. One of these two things is not allowed. Way back when you first learned about variables, I said that you should think about them like boxes with labels on them that store values. So the label, let's imagine the label is the data type. So the idea is the data type on your variable is a way of telling you what kind of object are you going to find in the box. So it's okay to store a grad student object inside a student box because a grad student is a type of student. That's not a lie. That's not misleading in any way. However, it is misleading to store a student inside the grad student box because a student is not a type of grad student. So I'd be upset if I looked in the grad student box and I found a student because this could be anybody. It's a more general category. More specifically, a grad student variable, there are certain methods that only grad students have. Only a grad student has the getID method. So if I put a student object inside this box, the student class doesn't have a getID method. So this would just fail. And that's why you're not allowed to store a parent class object inside a child class variable. Let's think about it this way though. The student, Here, my variable is a student. So let's think about all the different methods I could have a student do. Every single method I could have a student do is a method that grad students also have because they inherited them from student. So I can't get myself into the same kind of problematic situation. Here, I had a variable and I thought I could run a method on it, but it turns out that the object inside the variable didn't support that method. So that's why you can't do this. Over here, all of the methods that I expect a student to have, a grad student actually does have. So it's totally safe for me to store it inside there. Yet another way of thinking about this is you can always store an object inside a variable whose data type is higher in the inheritance hierarchy. This tree is sometimes called the inheritance hierarchy. Okay, what about this? Stanford student and grad student are both children of student. Could I take a Stanford student object and save it inside a grad student variable? I hope that you're thinking the answer is no, because the answer is no. And the reason why is because a grad student variable leads us to expect that we could run all the grad student methods. Stanford students don't have all the grad student methods, therefore we can't save it in there. Okay, I've been talking in a way that's intended to help you understand the motivation behind this. It might mislead you though, and I don't want to mislead you. What I just said, I said that this object has to have all the methods for the variable data type we're saving it into. What if I had my Stanford student and I gave my Stanford student another method that was getID? Now, the Stanford student does have all the methods that grad student has. So isn't it cool to save it in here? And the answer is no. And the reason why not is because the computer doesn't look to see are all the methods the same. Instead, the computer looks literally to see who is extending who else. So really what I said before is accurate. You can only save an object into a variable that's a higher data type in the chain. So it doesn't actually matter what the method lists are. My talk about methods was just intended to help you understand why that might make sense. Okay, so let's answer some of these questions. Question number 1, do grad student objects have a getName method? The answer is yes, because they inherit it from the student object. Do grad student objects have a name instance variable, and can a method in grad student use the name instance variable? The answer is yes, they do, because it's inherited from student, but a method in grad student can't use it because it's private to student. The only way the grad student can use that variable is by running public or protected getter or setter methods in student. What method does grad student override from student? And the answer is compute grade. Do constructors get inherited because they're public? The answer is no. Constructors are the only things that don't get inherited. How does a subclass call the constructor of the superclass or parent class? The answer is with the keyword super, followed by a list of arguments that matches the parameter list for one of the parent constructors. Would this be valid to save a Stanford student into a student object? The answer is yes, because a Stanford student is a kind of student. Stanford students have all the methods that students have, therefore it makes sense to save that object into this data type, because a Stanford student is an example of a specific type of student. Which version of the method will run if we say s.computeGrade? Okay, this is important. So let's say that we've got a Stanford student object being saved into a student variable like this. So both student and Stanford student have a compute grade method because the Stanford student class overrides the method from the parent student class. So which method runs when I say s.computeGrade? Is it the compute grade method for student because we have a student variable, or is it the compute grade method from Stanford student because we have a Stanford student object inside the variable? Here's what happens. Whenever you ask a variable to run a method for you, first the computer looks at the data type for the variable, and it says, is there a compute grade method for students? In this case, the answer is yes, but it doesn't run that one. Then it asks, what object is inside there? And is this method actually overridden? And the answer in that case is yes, it is overridden. So the version that runs is the Stanford student version, the version of the object inside. So this is okay, and the version that runs is the version of the object inside the variable. Okay, well, what happens if let's pretend that Stanford students have a method called getDormName. So this is a method that only Stanford students have. Normal students don't have dorms, so there is no method getDormName. Okay, so I've got a variable s. It's a student variable, but it contains a Stanford student, and that's okay. What happens if I try and run s.getDormName? Is that okay or not okay? This is not okay, because actually what happens is the same as in the last step I just described. The computer asks, okay, so s is a student variable. Does the student class have a getDormName method? And the answer is no. And because the answer is no, it just stops at that point. So the computer doesn't actually investigate what kind of object is inside the variable. So it only treats the object as if it is the variable itself, not what the variable contains. However, if you wanted to run the method, you could cast the variable. So I could take my variable s, which is a student variable, I could cast it to be a Stanford student. You have to have parentheses around the entire casting, and then you can run the method getDormName. The reason that's okay is because this variable actually contains an object that is a Stanford student. So it's perfectly okay to cast it to be a Stanford student. You can't just, in general, cast something to be something else. So, for example, I could not cast this to be a grad student, because that would sort of magically be giving this object new methods that neither student has nor Stanford student has. It would just magically kind of give it grad student methods, and that's not possible. So you can't just cast it to anything. You can only cast it to object data types that are further down in the object hierarchy. So let me say that one more time. If you've got a student variable that contains an object whose class is a subclass, you can always cast that variable downwards to be one of the child classes, and that's called downcasting. Okay, so back to our questions. Which version of the method will run if we say s.computeGrade? The answer is the child class version, because student has a compute grade method and it's overridden. So that idea where you'll run the child class version of an overridden method, that's polymorphism. Poly, of course, means many. Morphism means, morph means form. So polymorphism means many forms. So polymorphism is helpful because if you have a whole list of student variables, but it contains different objects. So it might contain a student object, and then a grad student object, and then a Stanford student object, and then a grad student object. That's okay, because remember, you can store subclasses inside a variable that's declared to be a parent class. So I can store all of these different kinds of student into an array list of student. The reason polymorphism is helpful is because I can loop over that list, assign each one to a student variable, no matter what type of student it actually is, and then I can ask that student variable to compute grade. And I can be confident that it's going to run the right version of compute grade. So when I grab a student, it'll run the student version of compute grade. When I grab a grad student, it will run the grad student version of compute grade. So it will run the right method for every single different subclass. Last but not least, is it valid to do this? So I make a new grad student, I save the grad student into a student variable, and then I run g.getID. So getID is a grad student method, but the answer is no, this is not valid because the variable we saved it into is a student variable, and students don't have a getID. So if you want to actually do this, you have to downcast it. You have to take your, what is this? So you could take your G variable, cast it as a grad student, save it into a new grad student variable, and then run gr.getID. That's okay. Or you could do that in a shorter way by just casting G directly as a grad student, and then put parentheses around the whole casting process, and then run getID. Okay, I know that was long. Thank you for listening. I hope it was helpful. This is like core concepts for both programming and also for the AP test, so you should definitely know them. Okay, see you next time.